Good morning, everybody, and thanks again to the organizers for putting this symposium together and focusing on renewable energy in the Southeast. I'm very committed to renewable energy, but the concept of eliminating golf courses for renewable energy, I'm not sure I'm in line with that yet, Sam. And DuPont has very strong ties to Denmark. In 2011, we bought Danisco, a very large enzyme and food and nutrition company based in Denmark that develops leading edge enzymes. So, Ambassador, we have strong connections there. I'm going to talk this morning about cellulosic ethanol. And are the charts up? There we go. And what's it going to take to create a cellulosic ethanol industry in the southeastern United States? But backing up a little bit, at DuPont and across the world and with the previous speakers, we really look at the major challenges that the world is facing in the 21st century. Demographics are such that we're going from 7 to 9 billion people in the next 30 years or so. The world is industrializing. The developing world is moving into the more modern economy. Food consumption is going up. Energy consumption is going up. And as the world becomes more dense, security and protection needs and environmental sustainability issues are becoming increasingly important. 1 out of 7 people in the world go to bed hungry. There will be an increase in energy demand of about 40% by 2035. So we have real challenges in the world today, and we believe very strongly that integrated science and strong collaboration between the public and private sectors, between people from the University of Georgia and Georgia Tech, and across the world can solve the challenges that we face in the world today. Congress recognized this in the transportation fuel sector. This chart shows the renewable fuel standard, which was passed by Congress. Both sides of the aisle supported it, something that doesn't occur very often, in 2007. The yellow bar on the bottom shows the mandate for the use of grain ethanol or corn-based ethanol in the United States. And above that shows the mandate for the use of advanced biofuels. Currently, the United States uses about 13 billion gallons a year of corn-based ethanol. This is about 10% of our transportation fuel supply. So in the chart that Sam showed earlier, showing the reduction in oil demand, a large part of that reduction was also due to the use of corn ethanol. Sam's shaking his head no, so he must have taken that out, backed that out, okay. So very significant contributions. Why do we, by 2022, the mandate requires obligated parties. So what are obligated parties? Obligated parties are anyone who blends gasoline and sells gasoline. So those obligated parties have to use an additional 21 billion gallons of advanced biofuel in the fuel supply by 2022. 16 billion of that needs to be cellulosic ethanol. So what is the driver behind this? The Republicans very focused on energy independence. And as the world's demand for oil increases, how does the United States take care of its own needs at home? Sustainability is the other factor. Cellulosic ethanol, the program that we'll be discussing today, has 0 carbon emissions. So essentially we're collecting agricultural residue which will degrade into the environment into carbon dioxide And instead of having that occur, we're converting that residue to biofuel and generating excess energy to run the biofuel refinery. And so we get a net zero CO2 emission. So outstanding sustainability. And it's also a big impact on rural economic development. And so if you look at what the grain ethanol industry has done to the rural economy across the Midwest, where manufacturing jobs were being lost in many small communities, the grain ethanol facilities and the infrastructure to support them have been an economic boom across the Midwest. This 16 billion gallons of cellulosic ethanol will require about 160 to 200 million tons of biomass feedstock. So a massive quantity of feedstock. And it'll also require about $90 billion in capital investment. That's a very large figure to industrialize the rural economy. So there's a great market opportunity here. It's mandated by Congress. It is the law. The law doesn't expire, I think in 2032 or something like that. So it'll take an act of Congress to change the law and the standard. So there's a tremendous amount of private and public money going into the development of advanced biofuels and cellulosic ethanol. There are challenges to this market creating mechanism. Many organizations have their interests which don't support the development of mandated biofuels, and so there's a significant campaign against the renewable fuel standards taking place today. This mechanism is critical to the establishment of the biofuels industry, in particular advanced biofuels. Without the renewable fuel standard, the large amount, over $1 billion, has so far been invested in the development of the technology. That investment by private industry will cease. And so maintaining the renewable fuel standards is a critical part of having stable policy which will allow the growth of this industry. You can see on the chart the current grain-based standard has already driven a $500 billion increase in America's farm assets. So whereas the farm economy was in real trouble across the Midwest, the establishment of the grain ethanol industry really boosted the farm economy. Fuels America is an organization. I encourage you to go to the Fuels America website. It's dedicated to preservation of the renewable fuel standard, and a number of companies are participating in this organization, and it's a critical part of our efforts to develop a cellulosic industry in the United States. So how is DuPont approaching the challenges and the opportunities that are created both by the megatrends and by the government policy and the renewable fuel standards? So, you know, DuPont's traditionally been a chemical company, thought of as a chemical company. Better things for better living through chemistry was our motto for most of the 20th century. We've changed that. We're now the Miracles of Science company, and we really have reinvented ourselves with a very strong focus on biology. And so you see on the right, we still are very strong in advanced materials, many polymers, protective materials, very strong in photovoltaic supply, so we're one of the world's largest suppliers of photovoltaics. But we've also, in the late 80s, began investing heavily in agriculture and nutrition. We own Pioneer Seed Company today, which is the largest producer of seeds going into the agricultural economy. And so now, how do we bridge those two? How do we bridge the traditional markets we've served as well as the agricultural world So we've put a tremendous focus on biology as a science. And how do we use biology to transform agricultural products into end-use products which meet the needs of the world as we move forward. Our first example of this is in Loudon, Tennessee. It's about 3 hours from here. In 2006, DuPont and Tate and Lyle, through a joint venture, started a company called DuPont Tate and Lyle Bioproducts. This is the world's leading example of biochemical production through a genetically modified bacteria. And so we take corn sugar, we convert that corn sugar through E. coli into 1,3-propane-diol. We get about a 50% reduction in greenhouse gases versus a competitive chemical route. And importantly as well, the economics of doing this through biology are much better than through petroleum. So you're enabling the development of an industry. We send this monomer to Kinston, North Carolina, another Southeastern Conference state. No, North Carolina is not in the Southeastern, all ACC in North Carolina. We send it to Kinston, and Kinston converts it to a polymer, and then that polymer is shipped to Dalton, Georgia, a little north of here, where it's turned into carpet. So we've developed a very strong bio-based supply chain. This carpet, made by Mohawk, is the best carpet you can buy. Naturally stain resistant, very soft, and it's grabbed tremendous market share in about 6 or 8 years. So a great example of what science can do in bridging the gap between agriculture and biology and in markets today. So as we look at cellulosic ethanol in a cellulosic biorefinery, and we think about how do we build this industry in the Southeastern United States. So that's really what I'm going to end up with today and what the challenges are. The good news is that the conversion technology to convert feedstocks to ethanol is developed. We're building a plant in Iowa, so we know how to do it. The feedstock supply chain is the real challenge today. I'll talk in a minute about what we're doing in Iowa, but if we look at how do we build a cellulosic ethanol industry in the Southeast, establishing an energy crop supply chain is the critical issue that we face. So what have we done in Iowa? DuPont is managing the feedstock harvest and development. So it's based off of corn stover. So when corn grows and the farmer harvests the corn in the fall, he takes the kernel off the corn, and today he throws the stalk and the cob and the leaves back onto the field. And then he comes back and he tills that into the field in most cases. So what we're doing is we're contracting with the farmer for access to his land. We then come back, we have to do this within 2 weeks of when he harvests the corn. And we come back with equipment that's subcontracted, and we collect the corn stover off the fields. We bale it, we transport it to storage sites, and then we feed that into our process, or we'll be feeding that into our process. We've completed a large-scale test harvest. We collected about 30,000 tons in 2012, and we'll be harvesting off of about 80,000 acres in 2013. So these are very large operations. A tremendous amount of commercial equipment is required, and understanding of the sustainability for the farmer is very important. So we're leveraging with our Pioneer company to understand and study all of the impact on the farm in terms of sustainability and management of the farm so that we don't do any damage. And in fact, what we're finding is that with proper management of corn stover, the yield on the farm actually goes up. So we're actually increasing the food production by properly managing the agricultural residue on the field. In terms of the conversion process, and I want to stress the collaboration, both in our feedstock program. We've been working heavily with Pioneer and with Iowa State. Our plant in Nevada, Iowa is about 5 miles away from Ames, where Iowa State is located. So as we work on sustainability with the growers in the area, Iowa State is a very important resource that the growers trust. The state of Tennessee has been very supportive to us as well. Governor Bredesen put $200 million into biofuels and helped fund the development of a demonstration facility in Vonore, Tennessee, which we have used to scale up from our bench scale process to a pre-commercial scale process where we can develop and collect the engineering data to build our plant, which is going to be built in Nevada, Iowa. Why Nevada, Iowa? I'll talk a little bit more about that, but it gets back to the feedstock question. The corn stover is available today on the ground. Switchgrass is really the focus of the state of Tennessee, but we have to learn how to establish switchgrass energy crop supply within the state. So what do we do? How do we take cellulose and convert it into ethanol? So first we take these 1,000-pound bales, half a ton bale, and we feed it into our process, into a milling operation where we grind it up. And then we have to separate the lignin or release the cellulose and hemicellulose from the lignin. So there are a variety of pretreatment processes that are used. We use a dilute ammonia pretreatment process. And so this is essentially a chemical reactor where we're introducing ammonia and we're breaking some of the bonds between the cellulose and the lignin. We then feed that material into a saccharifier, and Genencor, which is part of Danisco, has developed enzymes through genetic engineering that we then introduce into the process, and it converts the cellulose and hemicellulose into C5 and C6 sugar. We then convert that through a Zymomonas bacteria, that C5 and C6 sugar, to ethanol in a fermentation reactor, and then we run that through a fairly standard distillation process and evaporation process to recover the ethanol. So there's a lot of groundbreaking science in this process, and we're not the only ones working on it at DuPont. A number of other companies are working on similar processes, but with differences, and economics are critical to how we do this. But as I said earlier, the technology's demonstrated. We've completed our basic data development, and we're in engineering construction of a 30 million gallon plant in Nevada, Iowa, which will be starting up in the second half of 2014. It's a big challenge. The supply chain is huge. As I said, we have to be on the farmer's field 2 weeks after he harvests the corn, and the farmer takes the corn off the field in about a 6-week period. So we essentially have 6 weeks to marshal equipment and labor and contractors to collect about 375,000 tons of corn stover. That'll require about 190,000 acres of land to be contracted in a 30-mile radius of where the plant is. So we'll be contracting for about 20% of all the land in a 30-mile radius. So you can see the economic impact on all of those farms, on equipment suppliers, and all the infrastructure it takes to develop a cellulosic ethanol plant is very large. And this is to produce 30 million gallons of ethanol. So there's a lot of risk in this supply chain. We're very confident with the work that we've done and with our management practices and with our supply chain management techniques that we can make this happen. And we are demonstrating that it will happen. The challenge in the Southeast, as we talk about switchgrass as an energy crop to feed cellulosic ethanol plants, is that supply chain does not exist today. And so how do we develop that supply chain? And that supply chain is going to be required. You can see this is from a Department of Energy study completed in 2011, that today in 2012 there's about 235 million tons of agricultural residue of feedstock that have been identified as being available, with a significant portion of that being agricultural residue. Now, all of this feedstock is not necessarily economical to collect. And so one of the keys is that it has to be economical to collect so that we get the right cost in our processes. And so many people I've seen on the agenda, we have many presentations about feedstock. Always pleased from an industry perspective, the cost of that feedstock is a critical component because these processes are very expensive to build, much more expensive than a grain ethanol plant. And what we're relying on is low-cost feedstock to make it cost competitive in the industry. But as we move forward and as we build out this industry, it's very clear that perennial grasses are going to be required. And that creates the opportunity for the Southeast. So we're building our plant in Iowa. This shows crop residue. And you can see why the plant is going in Iowa, where you have very great density of residue in the cornfields. This is some of the highest producing states, 200 bushels an acre in the area around where our plant is. So there's a lot of residue on the field. And so as we collect that residue, the economics is very good. Not a lot of opportunity in the Southeast for agricultural residue, as you can see on the map. Where the opportunity exists is in energy crops. And so there's great opportunity. As we talk about a $90 billion investment, we have to build 250 plants, twice the size of what we're building in Iowa today. So we're going to build a 30 million gallon plant in Iowa. We need to build 250 60 million gallon plants across the United States to meet the renewable fuel standard by 2022. So that's a tremendous challenge. Now, the grain ethanol industry had 48 plants under construction at one time in the mid-2000s, 2007, 2008, when that industry was booming. And so we've demonstrated how it can be done. But there's a real opportunity for the states in the Southeast here. And so I really want to encourage people to really understand how do we establish this feedstock supply chain to meet the needs of the industry. And this is a comparison, you know, and on the agenda we're talking about a number of different crops, opportunities for energy crops. Near-term supply crop residues is the only thing really available today. And so that's why the first plant is in Iowa. We believe switchgrass is an excellent crop, energy crop. We've been working with Genera Energy, which was funded by the UT Research Foundation, and Genera grew switchgrass on about 5,000 acres around our Vonore, Tennessee facility. And so they've been studying how to grow switchgrass and have done it very successfully. So we believe switchgrass provides an excellent supply potential. and an excellent and can be a very reliable supply for the industry. And this is the challenge. So if we're going to build a $350 million plant and there's no raw material to feed the plant, that's a huge risk for a company to take. And so how do we balance the risk? And on the other hand, if we're talking about needing 100,000 acres of switchgrass to be grown to feed the plant, those farmers take a big risk. Is the plant really going to be built? So one of the challenges we have as we look at cellulosic ethanol in the Southeast is how do we balance the risks between these two strong needs. The technology is there. DuPont will license the technology. It's ready for deployment. In our business model, we're a big company, but when you talk about a $90 billion capital investment, we're nowhere close to being able to generate that type of capital. So it really is a collaborative effort across industry. We expect obligated parties to invest. The major oil companies are very interested, agriculture companies to invest, and private investors, private equity money. So we expect the money to flow into this industry from a number of sources. We're building licensing packages, and those are available to companies. We'll also provide enzymes, and we'll provide support so that conversion technology is there today. What we need to do in the Southeast is to establish the feedstock. So the market demand is there, so please support the RFS2. It's critical to the whole program and to the continued growth of this industry. But also, as you do your work, understand how do we work together to establish feedstock supply. There are various business models which can be put together. The farmers can supply feedstock. The plant owner may choose to lease land in the area around a plant and supply feedstock, or third companies may develop to develop the feedstock supply. So the business models are open. There's a lot of opportunity there. We believe public and private collaboration is going to be very important. State support, federal support for how do we establish the crop. So once the crop is established, the economics are fine. The real challenge is acquiring the land, planting the seed, and growing the crop for the first couple of years as the process is being built. So how do we de-risk the investment? This is very important to attract the investment. And how do we provide this state and federal support for crop establishment? And so as we look at growing this industry in the Southeast, we at DuPont believe this is the critical issue. If we can overcome this issue, we have a vision of cellulosic ethanol plants across the landscape. And these plants can be located, will be located in rural areas requiring economic development, produce extremely environmentally friendly transportation fuels, and help promote U.S. energy independence. And finally, we have to do this together. Collaboration between universities, governments, equipment suppliers, manufacturers, different components of industry. We all have to work together to make this happen. Thank you.